Section 1.5, Analyzing Graphs of Functions, Part 3. In this part of Section 1.5, we're going to explore the basic uses and graphing and some of the skills you want to be able to do using the graphing calculator. So to begin, before we jump into anything, I want to show you how to reset your calculator. This is something that we'll be redoing before quizzes and tests just to make sure everything's on default settings and nothing else is in the calculator that shouldn't be. So to reset your calculator, you hit second, plus sign, and then hit 712. And as you can see, it will tell you that it's cleared and reset. You'll be in radian mode, and you'll also be in function mode, which is really for this class where you want to be for the most part. There will be some times down the road we'll be able to change those modes, but just as a default, this is where you want to be. Okay, so you can go ahead and hit clear. Now, the first thing we want to talk about is finding minimums and maximums. Okay, so to begin, we have to learn how to graph functions to begin with. So let's begin with example A here. We're going to go ahead and graph this. To graph an equation, hit y equals at the top left. So we're going to type in x cubed minus 5x squared plus x plus 7. So you'll hit 5x, and the variable key is right here next to the green key. This is your x. And then if you want to raise it to a power, you can use the power key right here below the clear. Now make sure after you type that power though, if you notice, your cursor is in the exponent. So you need to hit the right arrow key once to get it out of the exponent. After that, we continue typing the rest of the polynomial. So minus 5x, and there actually is a button for squared, so we can use that. And that's nice because it automatically takes us out of the exponent. So we have 5x cubed minus 5x squared, so we're going to add an x and then add a 7. Once that's done, you can hit the graph button, and since we've reset the calculator, it is already on a default 10 by 10 window. However, if you ever do end up moving that window around, it's always helpful instead of hitting graph to hit the zoom key and then select the 6th option, zoom standard. By hitting 6, it automatically makes you look at a window that's 10 by 10. And that makes it a little easier as a good starting point when looking at different kinds of graphs. Now, in our first skill, we're looking to find relative minimums and maximums. Anytime you have something on the graph and you want to do some math with it, you want to use the calculate menu, which is the blue key right above the trace. So to access that, you'll hit the second key here and then the trace button to go to that calculate menu. So if we hit second trace, this is our calculate menu. This is the math we can do when looking at the graph. Now, again, we're looking for minimums and maximums. So if you look at it, we're looking at options 3 and 4. So let's begin with a minimum. So let's hit 3. And the first question our calculator asks us is, what's the left bound? So we need to move our cursor that's locked onto the function here to the left of where we think that we may have a minimum, okay? Now, it's kind of tough to tell because we have a little bit of a dip in here. The minimum might be in there, okay? So we're going to move just a little bit to the left of it, probably about right here, hit enter. The next question asks for is the right bound. So we want to figure out what's the right side of the area that we want our calculator to look. So we're going to move this just a little bit to the right side of where that little dip right in here is, and hit enter. Now, once you've established the left bound and the right bound, you've basically told your calculator this is the area around the graph where I think there's a minimum, and that's where you need to look. Now, the last question is guess. Now, what it wants you to do is move the cursor as close to the minimum as possible. However, if you just hit enter, it'll accomplish the same task. So I moved it a little bit, but we just need to hit enter. Now we know the ordered pair down here at the bottom where the minimum is going to be. So if I go over here and actually write that down, we're going to go ahead and round this to 2 places. Okay, so over here this is 0.54, comma 6.87. And this again was our minimum. Now in order to find a maximum, we would do the same thing. We would hit second, calculate, to go to the calculate menu, and this time we'll select the 4th option, maximum. And now I need to move again to the left side of where the maximum is, and again I think there's a little bit of a relative maximum right here around the y-axis, so I'm going to go ahead and put this just to the left of it and hit enter. And again, move my cursor just to the right of it, hit enter, and then for the guess, I'm just going to hit enter this time. So now it tells me where my maximum is. So in this case, my maximum is going to be at 0.12, and then the y value is 7.06, round 2 places. And again, that's my max. Now we want to do another example here with g of x, and so since we've already done 1, we need to go into the y1 and clear it out. So we need to select y1, and then if you hit the clear button, it'll delete the entire equation. For g of x, let's type in negative x squared minus the sine of x plus 25. So we'll hit x squared, okay, that shortcut square button makes that easy, minus the sine of x. Now if you notice when you select sine, it automatically opens parentheses. You need to close those. So right above the 8 and the 9, use those parentheses to make sure we close it, because this plus 25 is not inside the sine function. So we hit plus 25. Now one other note, because I just realized I messed up here. If you do miss something, you can arrow back over to the place you need to change it. For instance, I forgot to put my negative here. So if I go ahead and move my cursor over here to where I want to insert something, you can use the insert command right here. So if I hit second delete for insert, it'll blink, and then if I go down here to the negative, it'll insert that where I need it to be. And then I can just hit the right arrow key to get it back to where it was. So if you make a mistake, you can always go back and fix it. Now, I'd also like to point out how the negative here and the minus do look different. And that's important because the calculator understands the button here for negative and the button here for, the button here for minus and the button here for negative differently. So make sure you always use the correct one in the correct place. And again, let's go ahead and hit zoom 6 to make a nice 10 by 10 graph. Now, it looks to me like the graph goes up, probably has a nice peak and comes down, but I can't see it. So here's a situation where I need to change my window. 10 by 10 doesn't show everything I need to. So to do that, we'll go to our window button. And as you can see, our x minimum and max, as well as our y min and max here, are negative 10 to 10. The scaling just goes by 1, but that's the really important notes are the min and max. So based on the graph that we're looking at here, I need to increase my y. I need to increase the maximum y value. And I don't know exactly how much, so I'm just going to play around with it a little bit. So let's hit window. And I'm going to arrow down to my y max, and I'm going to make this 20 instead of 10. So let's hit graph. Okay, still not enough. So we're going to have to go ahead and do that again. And if you notice, I did hit graph to go back to the graph, because remember, we use zoom 6 to start out with a 10 by 10, but if you keep hitting zoom 6, it'll just go back to 10 by 10 every time. So once you're messing with a window, you use the graph key to return to it. So let's go back to window, and this time let's change our y max. Let's try 30. Hit the graph key. There we go. Now I can see the maximum. So it looks to me like there is no minimum based on the graph, and I guess I could zoom out a bunch and explore it, but I'm pretty confident this is what the shape of the graph is. So this one only has a maximum. So let's hit second, calculate. We're going to hit the fourth option for maximum. And again, let's get this cursor off to the left side of where I think it is. Hit enter. We'll move it over to the right side. Hit enter. As you can see, it shows me visually where the calculator is going to look. And for the guess, let's put this over in the middle and hit enter. So in this situation, it looks like the maximum is going to be at negative 0.45 and then a y value of 25.23. And this again was our maximum, relatively speaking. Now the next thing we want to do is look for intersections of a graph. So here I have two equations we're going to type in, and with that we want to figure out where do they intersect each other, okay? So obviously we have our previous graph here, we're going to clear that out. Also notice the window still has that 30 as the highest y value. When we type in these two equations, we're going to hit zoom 6 and again return to a nice 10 by 10 window to start out. So let's go to our y equals and hit clear to get rid of that last equation. So in y1, let's type in f of x, and in y2, we'll type in g of x, and they'll graph both times. The blue will be f of x, the red will be g of x. It kind of tells you what that's going to be. So here in y1, let's type in 3x squared button, minus 4x minus 2. Hit the down arrow to go to y2. Now we'll type this in. So x raised to the third power, arrow out of the exponent, okay, minus 5x squared, and then plus x plus 7. So now that we have all these in here, let's go ahead and take a look at it. And again, the window is still where it was before, so we want to hit zoom 6 for zoom standard to reset to a nice 10 by 10 graph. So a blue showing the parabola, the red here on the cubic, we want to figure out the intersection points. And it appears there's one here and then one down here. So to do that, again, looking at the graph, we use the calculate menu. So hit second, trace, and we're looking for an intersection. So we want to hit option 5. Now, instead of asking us for left bound and right bound, this time it asks us for first curve. And then it's going to ask for second curve, and then guess. First curve means we've locked the cursor onto the blue equation, and as long as we just use our left and right arrow keys, we can move the cursor along the graph to about where we think the intersection is. If you use the up or down key, it will switch the cursor onto the red graph or the blue graph. It'll switch between first curve and second curve. So stick with just using the left or right arrows. So moving the left, I was able to get to about where I think the intersection is. We'll hit enter. Now it locked the cursor onto the red graph, and it's asking me for where on the second curve do you think it's at? It is. And it already is where I think it is, so I can hit enter. And then as always, it wants me to put it as close as I can for the guess, but it is already in place, so I'll hit enter one more time. So the intersection between these two equations here is going to be at this ordered pair. So I can approximate this here to be about negative 0.77 and then 2.84. And again, that's what the first intersection between these two graphs. If I want to continue on and find the intersection here, I would repeat the same process. Now, the next thing we want to take care of are zeros. We want to find x-intercepts. So we have some brand new equations we're going to try that out on. And I've chosen these particular equations because I want to make sure we're exploring all the different types of things you may need to type in your calculator. So first off, let's clear these old equations out. So let's go to y equals, hit clear, and then we'll hit down and hit clear again. Now I'm going to arrow back up to y1. Now in the first equation, we have 4 log base 5 of x minus 1. Now, you may notice the graphing calculator here does have a common log and a natural log button, but this is log base 5. So I'd like to show you a new menu that you can use either in the graphing screen here, or if you hit second quit and go back to your main screen, you can use it here as well. The menu I want to talk about is the F2 menu. In fact, you know what? We should really talk about all the F menus because many of these are important. So by hitting alpha, the green button, and any of the top row, you can access F1 through F5. These are shortcut menus to bring up a lot of more advanced functions that otherwise you might have to do a lot of button pressing to find. So it's very helpful to have these shortcuts. If you hit the green button alpha and hit the top key here for F1, the y equals, this brings up a quick little shortcut key to type in fractions. Okay, so the first option is to make a fraction. The second one is to make a mixed number. The third option is the command that converts mixed numbers to improper fractions. And the fourth option is the command to convert fractions to decimals. Honestly, I use number 1 more than anything else, but these are all fraction commands. If you hit alpha window for F2, this is one of the most important menus because these are all the shortcuts to mathematical commands like absolute value, summation, some calculus stuff. Here's our logarithm. This is a radical with any index, and here's some combinatorics, right? Permutations, combinations, and factorial. So a quick way to access those, again, is the F2 menu. If you want to find them, they are located in the math menu for some other, button pressing, but it's easier just to use the F2. Now, in the future in this class, we'll need the F3 menu because if you select that, it's how you make matrices. The last one is the F4 menu that I want to highlight because that, on the main screen, can access what is typed into Y1 and Y2 and so on. We won't need that now, but later on that can be helpful. Now, the last one, F5, and I don't think I hit the clear button there. If I hit alpha F5, I believe that takes you to the graph and stuff. I'm not exactly sure if that's a preset one, but we won't really use F5. Honestly, F1 and F2 right now will be very important for us. So let's go back to our y equals. And again, I want to type in 4 log base 5 of x minus 1. So I'm going to hit 4, and then I don't want common log, so don't hit the log button, and I don't want natural log. I want log base 5. So I'm going to hit alpha F2, and remember the fifth one is log base. That command lets me type this right here in blue, right? It's going to be log, and I'll be able to type in whatever base I want. So I'm going to type that 5 to get me the fifth option. So the base is going to be 5, and then inside the logarithm, we need to write x minus 1. Now, we're going to stick with this one now and calculate the zeros, and we'll come back and try typing this one. So let's go ahead and hit zoom. That's not what I do. Let's hit zoom 6. Whoops. Zoom 6. There we go. So here's the graph of the logarithm, which I think you recognize having that vertical asymptote. It doesn't actually stop there, but the calculator doesn't have another point to connect to because it's so close to that vertical asymptote. Now we want to calculate this zero right here. Okay, so to do that, again, we're looking at a graph. Let's go to the calculate menu. So second, calculate. We're looking for a 0, so we're going to go option 2. So if I go ahead and move my cursor using my right arrow key here, I can get attached onto it here. Now again, it's asking basically the same questions as for max and min. It wants a left bound and a right bound and a guess. So let's get just to the left of the 0 and hit enter. Okay, I'm going to arrow this over to the right side of the 0, hit enter, and then we'll get a little close to where it is, and again, hit enter. And as you can see, it gives us the ordered pair 2, 0. So over here, the 0 is going to be at x equals 2, or if you want it as an ordered pair, 2, 0. Now let's try it with an inverse trigonometric function. Okay, going back to y equals, let's clear this out. Hit clear. Now remember, inverse tangent is right above the tangent button, so we need to hit second tangent. And inside of it, we'll do 2x minus 1. Okay, so now that we're here, let's go ahead and hit zoom 6. Okay, clearly we have a 0 somewhere in this region. So let's go ahead and calculate that. Second trace, so for the calculate menu, hit 2 for 0. I'm already basically on the left side of it. I'll hit enter. I'll move it over just to the right of it, hit enter, and then I'll move it over a little bit for a guess, I suppose, and then hit enter. So it looks to me like in this case, the 0 is at x equals 1/2, or as an ordered pair, 1/2, 0. Now the last thing we want to talk about is solving. Okay, so we want to be able to use the graphic calculator to solve an equation. And this is a pretty complex equation that clearly you would not want to do by hand. So let's talk about how what we just learned can be used to solve equations like this. First off, let's go to our y equals and clear it out. Now, of the two ways that you can, use your graphing calculator to solve equations, one of them is to leave this basic equation the way it is and not move anything around. Okay, so what I'm going to do is I'm going to type the left side into y1. I'm going to type the right side into y2. I'm basically going to graph each of these like they're separate equations. And because we're curious where they're equal, if I calculate their intersection, that's solving the equation. So let's go ahead and type the left side into y1. So this is going to be 2 raised to the x. Okay, and get that cursor out of the exponent and then go plus 2. In y2, let's type this in. Now this is a fraction, so let's go to that F1 menu. Let's hit alpha F1. The very first option is improper fraction, right? So let's hit 1. And now I can type a fraction in here. Now in the numerator, we have a cube root. Okay, now on the calculator here, if you hit second x squared, yeah, there is a square root, but we want a cubed root. So again, let's go hit alpha F2. And if you look down here at the sixth option, this is the radical with any index, right? So let's hit 6. And now I can type in the third root of, and inside of here we're going to do x plus 1. And make sure your cursor is under the radical. Now we're going to hit the down arrow to get to the denominator, and we'll just type in the quadratic x squared plus 2x minus 8. Okay, so now that we have this, let's of course hit zoom 6. And as we can see, the blue and the red, those are the two graphs. And it looks like if I solve the equation, there are two solutions, right? There's two of these. So what I need to do now is using that intercept command. So hit second calculate. We'll look for number 5, intersect. I'm going to move over here to this right here to get the first of the two answers. So we'll do it right here and hit enter. That's close enough. On the second graph, I need to get over here. So I hit the right key until I'm about close enough. Sometimes it's tough to get it really close. Just do the best you can. And then hit enter for guess. So here, as you can see, it does give us an ordered pair. But if you think about the way the equation is set up, it's the x value that's the solution to what we're talking about. So here, one of the answers is going to be x equals negative 3.88. Now, to find the other solution up here, you can repeat the same process, okay? Now, another way that we can tackle this, as opposed to using intersections, right, is to find zeros. Now to do that, okay, in case you didn't want to do intersections, what you need to do first is come over here and solve the equation for 0. So what I'm going to do is I'm going to write this as 2 to the x plus 2, and I'm going to subtract this whole fraction, right? This whole fraction with the cube root of x plus 1, and then with my x squared plus 2x minus a in the bottom, and set that equal to 0. So I just subtracted the fraction to the left side. Now, the reason I can do this is because by setting it up this way, if I graph this left side as one function and I calculate where are the zeros, the x-intercepts, that should give me the same solutions, right? There were two of them. This one was negative 3.88, and this one's, something about probably, 2 point something. So let's try that. Let's go over here. We'll clear these out and start over. So instead of using intersections, I solve for 0. Let's type this entire left side and graph that as one equation. So this is 2 raised to the x, arrow out of the exponent, plus 2. And now it's going to be minus, and to make a fraction, alpha y equals for the F1 command. We want the first option. And then we hit alpha F2, right, to get that radical here, option 6. So this would be the cube root of x plus 1. And then in the denominator, arrow down to that, we're going to hit x squared plus 2x minus 8. So again, now because I've solved this for 0 and graph this whole thing now as one equation, its x-intercepts should be the same thing, right, as calculating the intercepts here. You're just solving the equation in a different way. Instead of looking at where these two equal each other, we're looking at where their difference equals 0. So if I hit, zoom 6, it's only going to give me one graph, but now I have two different answers, right? I have an answer here and an answer here. Now, if you look at it, that does look like about negative 3.88, and we'll check that out. And this one is about 2 point something, which again, I thought to be the other one as well. So let's quickly do that. Second, calculate. We're doing a 0 this time, so we want to now hit the second option. We need to get to the left side of that 0, so let me move my cursor over. Okay, so, a little too far. There we go. Hit enter. Now move it a little bit to the right. Hit enter. Hit the guess. And again, as you can see, negative 3.88. So when solving equations, especially super complicated ones, you can either graph each one and calculate their intersection points, or you can solve for 0, graph that whole big equation, and find the x-intercepts. It's doing the same thing.